So we have seen the functional simulation process for the AND gate using VCS tools in the last video. So now in this video we'll see how to do the synthesis for the same AND gate using Design Compiler. So where we have used the VCS Synopsys and now we use the Design Compiler Synopsys. There will be first package VCS, second package Design Compiler we use one by one. So these two comes under the front-end design process for the any IC design. So when first two steps completed, it will be forwarded to the phase called the backend, where it starts with the physical design. We'll see it in the next video. So before going to the synthesis process, first of all we'll see that what are the contents required to do the process, where you can go into my channel and you can see the posts and use the controller where you can find that RTL, search with RTL, where you can see that a step-by-step procedure to do RTL to design flow, VCS design with different tools, VCS and DC and ICC tools, VEDD prime time. These all tools how it can be used, and the systematic procedure will be there in this document, and you can download the files which are required from this link. So once you open the link, you can find the following folders. You just download the folders, and this is where my tool has previously where we have done the simulations over here in the A1_YouTube. So this is where the folder where it contains the AND gate and the test bench. So AND gate file got simulated using the test bench in the last video, but right now after the simulation process is completed, functional verification completed, this test bench no longer is useful, so only we'll work on this one. So now just let me open this one and I'll show that the important content where you have to remember is AND gate is the module name, and the file name is AND.v. Just let me note it down before we go into the details, so that it will be clear, otherwise we'll have a lot of confusion. My module name is AND gate and file name is AND.v. So these details are very important. Wherever like I wanted to call the module or call the file based on the module name and file name itself. So this point just remember, and I will copy few files where I can do the simulation. So the files which are required to copy into my folder is, before can see this is the process of doing the synthesis, where I need logic library, cell library, standard cell library, and RTL code. So this is what RTL code I have over here in this file, and SDC file, constant file. Basically constant file is nothing but the user will tell you what will be the fan out, how many outputs that my circuit can drive, and the transition time of that particular cell, and interconnecting capacitance, how much it should be. These all details will be given by the user. As per the user constraints, right, we have to make the synthesis and we have to develop a circuit. So this file is also important. So RTL file and SDC file and the standard cell library files. So these three files we need it before you go with the synthesis process. That's why these three files from other folder, let me copy. So already I have downloaded and I'm keeping that all the files over here. These files already I've shown it. This is where the link from which you have to download, and once it is downloaded, now what I do is these files where I have it in another folder, now let me copy into my my drive where I'm doing the simulation and synthesis. So this will be my source, DC, this is the file I need, and constant files also needed, and a reference library. All the standard cell libraries I will be getting from this. So once you open it, you can see that what will be the content, technology libraries .db files, all will be available over here. So let me copy these three files now. So DC file, DC, and where my destination is, this is the folder where I am trying to do the synthesis. So this is my destination, where I will be copying this destination. Manually you can do it in your drive. When you open the Linux system, you just copy it and paste it, because I am not able to do it. That's why like I am going with the comments. So DC folder is copied. In the similar way, I have to copy the rest of the folders also, where I need another folder. DC is copied, constant folder is also required. Yes, copied, and reference folder is also required. Let me copy that also. Reference folder is also required. Yes, let me copy, and let me check all these folders got copied into my drive. This is the constant file folder where I got, and DC also I got, and reference also I got. So with these three files, what are the required that files I need, I got it, and from where we can do the synthesis process. So when we start with the synthesis process, what we need is our RTL file. Is it ready? Yes, it is ready as per the specification. And go to the DC Design Compiler, where I have the tickle command file, script file. So we have to run this file, and all the libraries will be added, and libraries will be invoked, and it will be run by this tickle command itself, script files itself. And only the thing what we do is we have to provide the path for each source files, and one by one that tickle commands will be executed, and with that synthesis process also will be done. So now let me change the path of the .v file where we have. So I can show you the .v file where it is there, where I have is, this is the .v file that I have. So let me copy the path. You can do one thing here, this is the folder. You can give the right click and you can type the command pwd, so that you can get the path. I could copy the path here, or else like you can do it from your end like that, and paste the path. And you have to remember that the file name you have to give it. So you have to give the file name. As I said, the file name is n.v. So we have to do the same thing here. We have to write it the same thing here, n.v. So okay, save it, and also I just need to do some other modification also in the tickle file, where I have to change the name of the SDC file. As I said, there will be SDC file also, we have to give it as input. So SDC file where I have is the constant file, where I have is, this is the constant folder where I have the SDC file. So now let me rename that SDC file. That is your wish, you can use the same name, or else like you can change the rename, you can give the another name. So end gate .stc, that is the name that I wanted to prefer. Let me change it. So after I change it, so the SDC name for this folder, for this file is, yes, you have to change that entire thing. You have to give the path where the SDC file we have. This is the path that I have, the SDC file. Let me copy, and the file name of the SDC is AND-gate. So AND-gate. So once like I give the Verilog file and SDC file, these two files, right, I have to provide as a inputs, and I have to add the standard cell library also. So let me save this one. And I have to go to the DC, and I have to go to RM setup, and I have to open this one, and at the design name, we have to change the design name here. SS is the name that I have right now. I have to change with the design name it over here. So as I already told that the module name or design name is same, my module with the name AND gate, this is what my design name, module name, that I have to replace it over there. So AND gate, so I will be replacing it over here, right? So the information that I have provided in each and every file, and now we can go with the process of doing the synthesis. So for doing the synthesis process, first of all we have to invoke the tool. Let me go to this folder where I have the DC, where I have the tickle command, tickle file, tickle commands with the tickle file, script file. I have to go to the particular path cd, and that particular path, I am there in this path now, and I have to execute this file, I have to run this file. And before that, let me open the tool, let me invoke the tool tcsh, and I have the tool it over here, that csh file I have to invoke, source the file, and now with the variable name which tool you wanted to access, either like custom compiler tool, VCS tool, DC compiler, the ICC, whatever the tool you wanted to invoke, just give the variable name of that particular tool. So I will be using DC compiler, DC shell, right? Yes, DC shell. Even you can see the procedure, what steps we have to follow in the previous document I have shared, right? So the DC shell is open now, and now I have to execute the each commands. Here the tickle commands that I have, I can open it and I can copy one by one and I can paste it over here, I can execute. Otherwise, right, you can run directly. Source run underscore DC tickle commands, that just I'll run it. With that, synthesis process will be done, and it will be showing that constants, and it will be showing that timing and power reports, and now I can use the start GUI, start underscore GUI, where I can open the window where I can show you the RTL view for the AND gate. So if I click on that AND gate, then I can give the schematic view, so I can see that RTL view. If I give double click, you can see that RTL view for the AND gate. So this is what the process of generating RTL view gate level schematic for the AND gate. After the process of simulation, once it is done, and we could do the synthesis and we could get the RTL view, and we'll see that how to generate the reports, and how these reports will be given over there to the process of physical design, where backend process gets started in the next video.